Okay, class, in this lecture we're going to be talking about linear and angular velocity, and velocity is another word for speed. Okay, so I'm talking angular, I'm talking about going about a circle. So I have a circle, and I want to talk about some conversion factors and formulas that we're going to use when we're going to be converting between different units to find a linear or an angular speed. So 1 revolution, so let's just say you start your bug on a tire and you're going to make 1 revolution, or 1 rev. Okay, so that's 1 time around. Well, that's the same thing as going 1 full circumference around the circle, and you know that the circumference from geometry class is 2 pi r, where r is the radius of the circle. And if you've made 1 full circumference, then you've rotated 360 degrees, or 2 pi radians. So these are all of the conversion factors and formulas that we're going to use when we're converting units between linear speed or an angular speed. And we're just going to use dimensional analysis. So the one thing that I do want to point out is you have 2 pi r, 2 pi times the length of the radius, which is the circumference, and 2 pi radians, which is an angle measurement. So we do have a circumference and 2 pi r. That is a linear distance. Okay, so I know the circumference is the distance around, but if this was, say, a piece of cooked spaghetti and you opened it up, the circumference would just be that straight piece of spaghetti. Okay, it's a linear distance. Linear units would be things measured in inches or centimeters or miles and so on. Those are linear things that measure length. Okay, we also have 360 degrees or 2 pi radians, and those are angular measurements. Okay, so angular measurements measures the amount of angular rotation. Okay, so if the bug started here and ended here, I want to know how many angles did it move? Did it move 40 degrees? Did it move pi over 3 radians? Okay, so for linear speed, we'll measure how fast an object moves around a circular arc. Okay, so how much it moves from here to here. And that linear speed, it's just the speed, like like distance over time, like 55 miles per hour. That would be an example of a linear speed. An angular speed measures how fast the angle changes. If you're turning really fast, you might turn 360 degrees in 1 second, or 360 degrees in 5 seconds, would be moving slower, it'd have a slower angular speed. Okay, so let's do some example problems. Example 1 says a wheel with a radius of 20 inches turns 35 revolutions per second. What is the angular velocity of the wheel? So angular velocity means we're going to want some angle measurement over some time measurement. Okay, so in the givens, we're told it turns 35 revolutions per second, which means this wheel turns around 35 times per second. So our time unit is going to be seconds, because that's what we're given, and since it doesn't specify specifically in minutes or something, we can have it in any. And it didn't specify angular velocity if it wanted in degrees per second or radians per second. So I'm going to go ahead and start off with degrees, since it didn't specify. So I want degrees per second. I want a rate, degrees per second. So I'm going to start off with a rate that we were given, which is 35 revolutions per second. Now when we're doing our conversion factors, we are going to do dimensional analysis. So we are going to write a fraction with the horizontal fraction bar, 35 revs over a second, and then we're going to multiply it by one of the conversion factors that I gave you on the previous page. Now we want to convert from revolutions to degrees. We already have seconds, and I know part of that was that 1 revolution is equivalent to 360 degrees. So then the revolutions cancels with the revolutions. And it's legal to multiply by this because this is our conversion factor. 360 degrees equaled 1 revolution. So 35 times 360 is 12,600 degrees per second. And that is the angular velocity of the wheel. Okay, so we said the bug sits on the outside of the wheel. How fast is the bug moving? Well, how fast? Well, that's just, how fast do you drive to school? That's a linear speed. So we want a linear speed. Okay, and that is some distance over time. And we're given a linear distance of 20 inches. So I'm going to want it in inches per time. Well, we still have our seconds. So I'm going to want my answer in inches per second. Okay, so again, I want a rate, which is distance over time. So I'm going to start off with a rate. So again, I'm going to start off with 35 revolutions per second. You could have started with the answer. That's also a rate. And I'm going to multiply this by something to go from revolutions to inches. So in that long list of conversions that we had, the linear conversion we had to do with the circumference. So whenever you want to get to a linear distance or away from a linear distance, we're always going to use the circumference, 2 pi r. So 2 pi r is equivalent to 1 revolution. So we can get rid of the revolution and then get 2 pi r, and r is going to be 20 inches. Okay, so I know the circumference, 2 pi times r, 20 inches, is equivalent to 1 revolution. So this is the conversion factor, because going one circumference around the circle is equivalent to 1 revolution, going one time around. So revs cancel, and I have 35 times 2 times 20 pi, and this is going to be 4,398.2297 inches per second. Okay, and since these two were word problems, we should have sentence answers, which I wrote down. Okay, so let's go ahead and move on to example number 2. Okay, and the second example is a car travels 65 miles per hour. The radius of the tire and the wheel is 20 inches. How many revolutions per second does the tire make? So I want revolutions per second. I want revs per second. So I want a rate, so I'm going to start off with the rate given in the problem, which is 65 miles per hour. So I have 65 miles per hour, and this is just dimensional analysis. So I'm going to start off by converting from hours to seconds. So I know that 1 hour is 60 minutes, and I know that 1 minute is 60 seconds. Okay, so this is a basic dimensional analysis. So now I have miles per second. I got seconds in the denominator, which is what I wanted. So now I have to go from miles, which is a linear distance, right? It measures a length, miles, and I want to go to revolutions. So whenever I want to get rid of or get a linear distance, I'm always going to have to introduce the circumference. Okay, so I want revolution. So 1 revolution is 1 circumference, which is 2 pi r, and the radius of the tire and the wheel is 20 inches. So I have 20 inches. Okay, so now I have revolutions and I have inches. That doesn't cancel with miles. So now I have to convert from inches to miles. Now in your planner, it does have some conversions. I know that there are 12 inches in 1 foot, so I can get rid of the inches, and I know that there's 5,280 feet in 1 mile, and foot cancels with foot, and then my mile cancels with miles. So the only units that I'm left with is revolutions per second, and all the other units canceled, 1 on top, 1 on the bottom. Now this is why I have the strict requirements of where you need to write your fraction with your horizontal fraction bar, so you can easily see what's on top and what's on bottom. So one thing on top cancels with one thing on bottom. Okay, so now I just, on the calculator, 65 times 12 times 5,280, divide it by, and you're going to need parentheses, 60 times 2 pi times 20, close your parentheses, and you should get 9.1037, and the units are revs per second, and I'm going to write that in a sentence. Okay, so the car goes about 9 revolutions per second, and I said 9. I boxed in the 4 decimal place answer, so that should be sufficient. Okay, the second part says, what's the angular velocity in radians per second and degrees per second? So I'm going to want both. Okay, so I'm going to start off by finding the radians per second. So I'm going to use some sort of rate. And I'm going to start off with the rate I have here, 9.1037 revs per second. And I want radians per second. So to go from revs to radians, if you have a circle and you make 1 revolution around the circle, that's the same thing as turning 2 pi radians. So I know that 1 revolution is equivalent to 2 pi radians or rads. So the revolutions cancel. And I'm just using the previous answer in my calculator and timesing that by 2 pi. And I got 57.2 rads per second. I'm just running out of space here. So I'm going to go ahead and round to 1 decimal place. Okay, so since I said the standard will be 4 decimal places unless stated otherwise, so for that one I'm just going to round to 1 decimal place. And then the other part, I need to do it in degrees per second. So again, I'm going to start off with the answer we had in the calculator, 1.037 revs per second. And if I have a circle and I make 1 revolution, that's the same thing as turning 360 degrees. So I can multiply it by 180 degrees is equivalent to pi radians. Sorry, let me back up. I'm doing something backwards here. To revolutions, 1 rev is equivalent to 360 degrees. And the revs are going to cancel. We're going to have our answer in degrees, which is 3,277.3 degrees per second. And again, to round it to 1 decimal point. And we are going to have a sentence answer. Okay, so I went ahead and wrote a sentence, and I just said the angular velocity of the tire is about 57 radians per second, or 3,277 degrees per second. So the reason I wanted to do it in radians and degrees is really to show you that the radians might not be that clear to you how much 57 radians per second is. I don't really, off the top of my head, can't tell is how fast or is that slow. But if you look at it as 3,277 degrees per second, it's turning 3,000 degrees every second. That's a lot of turning. Okay, so that's pretty fast. Okay, so that's all I wanted to teach you about linear angular velocity, so I hope you have a wonderful night.